Are you ready, kids? Aye, aye, Mr. Gala. I can't hear you. Aye, aye, Mr. Gala. Oh, who's learning about magnets in physics class? The junior class. I don't know the rest, but that's what we're doing. Magnetism from electricity and the magnetic force. So, a couple quick things. Now, magnetism and electricity actually go hand in hand. And so, I'm going to just kind of tell you guys a couple quick facts. Just like a long, straight current-carrying wire actually creates its own magnetic field around it. Now, if you guys don't believe me, you guys know, probably some of you guys know, when you guys are listening to the radio and you guys drive kind of near one of those power lines and the radio gets all staticky, it's because of the magnetic field that's generated by those power lines. Now, one of the crazy things is yesterday we talked about this idea of using compasses to detect magnetic fields. Compasses can actually show the direction of the magnetic field that's induced by a wire. Now, we get this thing that's called the right-hand rule. Now, it's called the right-hand rule because you use your right hand. And so, our first right-hand rule actually goes along with this idea of a current-carrying wire. So, if we have this current-carrying wire, it's pretty easy overall. No, we don't want to switch to tablet mode. So let's pretend our current is going up. Now, this is going to sound silly, but I want you guys to pretend that you guys are reaching out to grab that wire with your right hand. Remember, it's the right hand rule, not whichever hand rule. So your right hand reaches out. You're reaching for this wire. Now remember, you want to grab the wire. So if you're going to do it with your right hand, your thumb would be going up. Oof, it's a weird looking thumb. So your thumb's going up. There it is. And the rest of your hand is going behind the wire, and it wraps around the wire. That's an awful looking hand, but you guys get the idea. And so what that means is, in order for you to grab the wire, on the right side of the page, you're reaching in, and on the left side of the page, your fingers will be poking back out. Now, that kind of shows us this idea that our magnetic field is going in this side and out this side. And that's where that idea of a cylindrical magnetic field comes from. And so we get this magnetic field that's created as going in around the back of our wire and back out of the front. And so it makes this kind of circle, just like your hand, as it wraps around the wire, would begin to make a circle around it. Now, remember, yesterday we did have ways of showing in versus out. Hopefully you remember. In was X's. And so when we draw this, let's just draw it in this section here. If we're trying to draw the magnetic field through this section, we would draw X's on the right side of our wire and dots on the left side of our wire, which shows that our magnetic field is going in on the right and out on the left. Now, with this idea of having a current-carrying wire, I can't change slides. Oh God, I promised you guys 5 to 7 minutes. Oh no. Ah, there. Okay, I was able to switch it. But because we have these loops of wire that create magnetic fields, or this wire in general that creates a magnetic field, remember we were just talking about it, right? We got a current-carrying wire. If current's going up this way, that means it's going in on this side and out on this side. And so with this kind of basic idea, if instead of it just being a straight wire, let's pretend that we make it a loop. Now if we make it a loop, the same idea is true. Let's pretend we have current still going up this way, just so it's similar. But we get this idea of these X's on one side of our loop and dots on the other side of our loop. Now, what this does is it creates a much stronger magnetic field. And so this magnetic field, there we go. It's very similar to that of a bar magnet. So yesterday we talked about how a bar magnet has a north and south end and it goes out of the north into the south. So it follows this nice pattern. Now, whenever we make loops of wire, it follows a similar pattern. We get it to go out from one side and into the other. And so whenever we do this, we're actually creating what's called an electromagnet. Now, one thing about electromagnets is you guys are actually going through the process of creating two of them with your motor. Now, these are called solenoids. Now, solenoids, what they do is they take several loops. Now, when they combine several loops, it actually makes a much stronger magnetic field. And so we have this current going in, it goes all the way through our loop here, and then pops back out the other end. And by doing this, and stacking all these loops one on top of the other, we get this gigantic magnetic field that gets created. So much stronger than it was as just a single loop. And that's actually kind of one of those crazy things, because the more current we pump in, the stronger the magnetic field gets. And so that's actually what allows cranes to pick up cars. Maybe you guys have seen it where it's got the big gigantic, it's not really like a claw, but it's just this flat bottom thing, and you guys might have heard it's an electromagnet, but it picks that car up, carries it away. It's just a really, really strong solenoid, right? And so solenoids are very, very similar to just single coils of wire, but the idea is the more loops strengthens the magnetic field. And so if we place an iron rod in the center of the field, this kind of actually strengthens it because it adds in this extra layer. And this is actually one of those kind of really cool things that I'm going to show you guys in class tomorrow. So get pumped. That's it. Good luck. Have fun. I'll see you guys in the morning.